So hey guys, welcome back to another video. Let's learn about application layer. So what we will do now, we will separate out the web layer from the application layer. So whatever application layer, we will try to separate the front and back end and whatever web servers and whatever thing we will separate out. So single responsibility principal advocates, like for small and autonomous services that work together, small teams with the small services can plan more aggressively for rapid growth, right? So if we separate out, the thing is we can distribute tasks according to the team. There can be a backend team, there can be a front end team, there can be a team that is working on just load balancer service, there can be a team working on web server service and database. So the task can be distributed accordingly. How we will separate, let me show you. So this will be our request object, this will be our load balancer. Let's say these are our web servers web servers, and this is our platform server, pls els and pls. Okay, and then there are our database. Now request will communicate with load balancer communicate with the web server depending on how it's configured. Web server can communicate with pls, each web server can communicate with any. Okay, so this can communicate with anyone. Now pls will communicate with db. Okay, so both can communicate with any db. So that's how we are separating the application layer. Now what are disadvantages of it? Disadvantages. What are disadvantages? So first is adding an application layer with loosely coupled services requires a different approach from an architectural, operations and process viewpoint. Okay, so adding an application layer with loosely coupled services. Loosely coupled means those are not tightly coupled, those are loosely coupled. Different approach from an architectural, operation, process viewpoint. Second is what microservices can add more complexity in terms of deployment and operation. If you are dividing the services, those are microservices, right? This, if you are dividing it will become microservices, and these are more complex in deployment because you need to make sure you configure IP address or whatever DNS you need to configure on each service, or maintain a file or update that file according to that. So the complexity increases for deployment, right? So complexity increases for deployment, so that is there, it will get increased. Okay, application layer, right? Now after application layer, what are the topics? There is databases, right? So application layer, so as I said, a microservice, right? The complexity for deployment increases, right? So what we can use, there is this service discovery. What services we can use, right? So we can use Consul, etcd. If you use Docker, you might know this, and Zookeeper for deployments, of course. So it can help services. Find each other by keeping track of register name, address, and port. And there is one more. So it keeps addresses and all in their data, and make sure that server can find each other. Okay, so that is there. And second is health checks. Health checks help verify service integrity and are often done using an HTTP endpoint. So this helps in make sure that your service is up all the time. And like both Consul and etcd have a built-in key value store that can be useful for storing config values and other shared data. So that is health check and etcd Consul or Zookeeper can help in keeping your data intact or making sure microservices communicate with each other in a good way. Now do you guys know what microservices is? If you don't know, let me try to explain it. Microservices are independently deployable small modular services. Like each service runs a unique process and communicate through a well-defined lightweight mechanism to serve a business goal. So each service is independent of other service. So even if we take down any one service, it shouldn't affect any other service. It should be loosely coupled basically. So that is there. And so like Pinterest, for example, could have the following microservice. It can have user profile, it can have follower, it can have feed, it can have search, photo upload, etc. Photo upload can also be by social media websites like LinkedIn, Facebook, Instagram, Twitter, and whatever other social media platform you use. So this is basically what microservices is. Right, now let's learn about databases. Okay guys, so databases. One more thing, the previous video that I shoot, the audio got messed up because I kept my speaker on, so that I think got interrupted. But what can I do? I will try to. I'm not sure what I can I do now. But yeah, databases. What are database? Database, you know, right? SQL, NoSQL, MongoDB, Postgres. So these are type of database that we use in our day-to-day life. In the backend, of course, not normal people, but the developers do use it. So databases, like picking the right database for a system is an important decision, right? So whatever system design that you are creating, picking right DB is very important, right database. Okay. So as it can have a significant impact on the performance. If you don't pick the right database, your system can perform very poorly, and it can affect on your scalability, overall success of the system. So some of the key reasons why it's important to pick the right DB include, of course, the performance. First is performance. If you want a good performance, if you want it to be scalable, right? So like for performance, different database have different performance characteristics, and choosing the wrong one can lead to poor performance. So what it means, if you want good key value pairs, use Redis. Of course, for caching, not as a database. If you want to object blob data, use MongoDB. If you want to store mappings, use SQL, right? So because those databases are basically created for those, keeping that things on the priority. Now scalability. As the system grows and volume of data increases, the database needs to be able to scale accordingly. Some databases are better suited for handling large amount of data than others. So if scalability is an issue, try to configure the database which can serve large requests, okay, or large data modeling. A different database have different data modeling capabilities, and choosing the right one can help to keep the data consistent and organized, right? So data modeling capability means if you want to store an object or whatever you want. Sorry guys, it's a background noise. Now comes data integrity. Okay. What is data integrity? Now different database have different capabilities for maintaining data integrity, such as enforcing constant and can have multiple different levels of data security, right? So if you want your data to be secure, you can use those type of database which make sure your data is secure from attacks or whatever, right? Now comes support and maintenance. Okay, support. This is also very important point. Support. So try to pick the database which is maintenance. So try to pick a database which has more active communities and better documentation, which is more active. Okay. So like overall, by choosing the right database, you can ensure that your system will perform well, scale as needed, and can be maintained in the long run. So that's all about database. Now let's learn about type of databases, right? This is very important. So first is SQL versus NoSQL database. Okay, so let's learn about this. SQL versus NoSQL DB database. So SQL, what are SQL database? SQL database can be such as MySQL, PostgreSQL. These are best suited for relational data and use fixed schema. Right? These have schema and are good for relational database which have more relations, relational DB. Okay, good for it. We can create a star. It's a good for it. Okay, they provide robust ACID transactions. ACID means atomicity, consistency, isolation, and durability. You can learn more about it. Just try to find it in GFG or whatever website you will be comfortable with. So it supports robust ACID transactions and support complex queries and joins. So this is the benefit of SQL DB. Now what is a NoSQL database? NoSQL database which doesn't have fixed schema or not support. It supports relational, but it's not at that level. So let me just use that. So MongoDB, of course, first example is MongoDB. Cassandra is also NoSQL database. It is best suited for unstructured, like blob I said, right? Blob or objects if you need to store objects. So social media platform like FB, Facebook, LinkedIn, those sort of, it's good for them to use MongoDB because we need to store in the object format, right? User details and other things. So they provide high scalability and performs for large amount of data and are often used in big data and real-time web application. What is big data? So the study of data is known as big data. The study of data, like let's suppose big data means when you have a lot of data and you try to accumulate that data and perform some activity or try to analyze that data to create some suggestions or some decisions, to take some decision, that study is known as big data. Okay. Now the choice between SQL and NoSQL depends on the specific use case requirements of the project. And if you need to store and query structured data with complex relations, and SQL is likely a better choice. Like if you need to store and query structured data with complex relations, SQL should be the one you should go with. And if you need to store and query large amount of unstructured data with high scalability and performance, NoSQL is the way to go. Okay, so that was about SQL and NoSQL. Now let's learn about NoSQL database. Okay, NoSQL. Okay, NoSQL DB. First, let's learn about key value store. What is key value store? A key value store generally allows for O of 100. If you know DSA, right? Constant. This is constant, right? O of 100 means it's fast. So this allows in fast read operations, read and write. So it's often backed by memory or SSD. So their read and write are faster. Okay. So data stores can maintain keys in lexicographic order, knowing efficient retrieval of key ranges. Key value stores can allow for storing more of metadata with a value. Key value stores provide high performance and are often used for simple data models. Like key value pairs, you can see like Redis, which we use for caching. So that also use key value stores such as in-memory cache layer. Since they offer only a limited set of operations, complexity is shifted to application layer. Like if there is any complexity, that is shifted to the application layer or the servers. So that is what key value store is. Example is of course Redis is the example. And yeah, that's about key value pair. We'll continue in the next video.